MDM4U 5.2 Combinations. A combination is a selection from a group of items without regard to order. The number of combinations of R items taken from a list of N items is denoted NCR, CNR, or NR, and equal to N factorial divided by R factorial times N minus R factorial. So we're going to compare combinations and permutations. A 5-member team must select 2 people to present their research. How many different ways can 2 members be selected? So if we were to list each and every single possible outcome of selecting 2 people, notice that a selection of AB is really the same selection as BA, because if we are just selecting people to present the research, order does not matter in the selection. And we can think of this as a set where the order doesn't matter. So the number of permutations are listed here. This is a 2 by 10 grid, so there's a total of 20 cases. But when it comes to combinations, we're only going to consider those unique sets where each of the elements, it does not matter the order that they're written in. So, for a set selection of 2, there's 2 factorial ways in which that can be rearranged. Namely, 2 factorial is 2 times 1, 2. And that makes sense because if we have AB, there's BA that needs to cancel. And for each set in the top row, the matching set in the bottom row needs to be eliminated if we're talking about combinations, because AD is the same as DA when we're talking about combinations. So that being said, a selection of size R can be rearranged in R factorial ways. If there were more elements, our selection size was 2, there would be R factorial ways to select that many items. So let's look at this example to contrast permutations and combinations. 10 athletes are competing in the 100-meter dash. How many different ways can gold, silver, and bronze be awarded? So we need to ask ourselves the question, does order matter? And yes, it does, because we are assigning a rank, gold, silver, or bronze, to each of the athletes. So therefore, think of fundamental counting principle. We could say that this is 10 people could be selected for gold, then 9 choices for silver, then 8 for bronze. Another way of saying that is 10p3, because 10 pick 3 is going to be equal to 10 times 9 times 8. But we can think of this as a permutation, a selection where order matters, of size 3 from 10 elements. Next, how many ways can 3 participation ribbons be distributed? So we were selecting any 3 people at random, and participation ribbons do not have any rank relative to one another, so therefore we can see this as a combination. The order in which we distribute the participation ribbons does not matter. So therefore, this is a combination of 10, choose 3. And we do not need to use this definition every time that we do this calculation. This button should be on your calculator, and if you're having difficulties finding it, make sure that you ask your teacher. 10 choose 3 is 120. You should be able to go straight to this step. Now, that being said, what we're going to do is look at some more complicated cases. Combinations involving grouped elements. A teacher is selecting 3 students to do presentations in a class with 6 boys and 4 girls. How many different ways can the teacher make a selection without any boys? So if 0 boys are being selected out of the 6, and out of the 4 girls we are selecting 3, we can think of this as the following product. 6 choose 0, because out of the 6 boys, we're choosing 0 of them, that's equal to 1 on your calculator. And some people choose not to write this step. I like to do this to make sure that I've accounted for each of the subgroups in this problem. 4 choose 3 is equal to 4, because if we have a combination of four options for our selection and we're selecting 3 of them, we can think of the number of ways in which we're excluding 1 is the number of combinations. But you can check on your calculator. This is equal to 4. Next, how many ways can a teacher make a selection with 1 boy? So out of these 6 boys, we're going to choose 1 of them, because that's the number of ways we can choose a boy, times the number of ways that we can choose the remaining amount of girls. So if we have selected 1 boy, the remaining number of girls is 2. Next, how many ways can a teacher make a selection with 2 boys? So if we make a selection of 6 choose 2 boys, we still have a remaining 1 person to check from, or to select from the girls. And similarly with all boys, our selection size is 3. So if we selected 3 out of the 6 boys, then there'd be remaining 0 girls to select. Now 4 choose 0 is again equal to 1, but I like to put that there as a product because it helps me keep track of each of the different groups. So the sum, notice 0 and 3, 1 and 2, 2 and 1, 3 and 0, all add up to 3, our selection size. All right, let's think about applying the direct method versus the indirect method in the context of combinations. A hockey team has 6 junior and 9 senior players. If 5 players are selected to start, then how many ways can the coach make a selection with at least 1 junior? So, would you use the direct method or the indirect method? What I'm going to show you isn't necessary to write out. I know it may look complicated, but we're going to think of the spanning set for the number of juniors selected. Remember that in set notation, S represents the universe, and this is the number of ways that juniors can be selected. And this is our equal sign. Now the equals inside of this bracket, this is the number of ways in which j can be equal to 0, whereas the variable j is representing the juniors. We could have 0 juniors. We could have 1 junior in that selection, 2, 3, 4, or 5 juniors in the selection. So this is the spanning set for the number of juniors selected in this group of 5 made out of this team. Now, if we were to look at the cases which are of interest, at least 1 junior, the selection that I'm highlighting involves 1, 2, 3, 4, 5 cases to calculate. If I were to calculate this directly. Now, a way to avoid that is take a look at the other cases. This is all cases, and this is having 0 juniors selected. If we were to subtract selecting 0 juniors from each side, we would end up with the following expression. It's like moving this to the other side and it becomes negative, or subtracting that value from each side of the equation. And then we've isolated this right-hand side. Notice that j is equal to 1, 2, 3, 4, and 5 could be abbreviated as n, the number of ways that the juniors is greater than or equal to 1. So this is using an inequality operator. So this is not necessary to write out, but it is the foundation for understanding the direct method versus the indirect method. Think of all cases in the spanning set, and what is the least amount of work? The less work, the less likely to make an error. So we're going to implement this. I'm going to put this on the right-hand side, on the left-hand side, just switching left and right. So now we need to calculate the total number of ways in which we can select 5 players without any restriction. So that being said, there's 15 players on the team, 6 plus 9. Altogether, there's 15 players. And how many ways can we select 5 of them? Minus the case that we wish to exclude, and that's a key component of the indirect method. We take all cases and subtract the cases that don't satisfy our condition. This is 0 juniors and 5 seniors to make up a selection of 5. And we can evaluate, and this is our total. Now let's look at this case with at least 4 seniors. So this is, again, only for instructional purposes. I'm showing a spanning set so that we can think of our strategy to approach this problem. At least 4 seniors. So in this case, capital S represents all cases. Lowercase s represents the number of senior players selected in this group of 5. So we could have 0, 1, 2, 3, 4, or 5 in a selection of 5 hockey players. In this case, we are interested in at least 4. So that includes 4 or 5. Therefore, what we need to do is just calculate these 2 cases. Remember, with additive counting principle, we can think of this as either 4 being selected or 5 being selected. So we can add these 2 cases together. And this is, again, an abbreviation using an inequality operator. The number of ways that the seniors selected is greater than or equal to 4 is selecting 4 or selecting 5. So we calculate that by saying from the juniors there's 1, and then from the seniors, which is 9, there's 4 being selected. A total of 5 is selected, 4 of which are coming from the seniors. Plus, because this is the next case of selecting 5 seniors, that would involve 0 juniors. And out of the 9 seniors, we're selecting 5. So we calculate and add, and that's how we approach this problem using the direct method.